lab, what we're going to do is we're going to look at a device attack. Remember, there's going to be devices usually when we're doing red teaming between us and the target. So what we're doing here is we're using a tool called Dynamips, which it has a GUI front end called GNS3, but instead of using GNS3, because it's a Windows type of environment, I'm using the actual command line version called DynaGen. So if you look here, I've actually done an ls on this directory, and you can see the actual files that are in this system right now, this Ubuntu Linux. So what I do is I'll do a more of simple1.net. And what that shows you is this is actually the DynaGen configuration file. What it shows you as you look here is F00, ETH0, F10, ETH1. So what we're going to do here, we're going to actually boot, as you see here, a Cisco 7200 router image. So this router image is a true router image of a Cisco, so we can emulate an entire Cisco 7200 all within this one machine, all right? So what we do is we're going to start it. So we just do an ls again, and Dynamips is what we're going to start. So if I go a Dynamips, so a Dynamips dash uppercase H 7200. What this says is run Dynamips on port 7200, and I'm going to run it in the background. As you see, Hypervisor TCP control server started on port 7200. So this tells me that Dynamips has actually started. So the next thing is our configuration is the DynaGen. So that simple1.net file is what we use for DynaGen. So what we're going to do is we're actually going to do the DynaGen. So now we just do a /DynaGen simple1.net, and hopefully it will start. And again, I didn't need the /. So now as you see here, it goes up and it starts loading the image, and eventually it's starting an R1 instance, and there we go. See this prompt right here? This prompt tells me DynaGen has started. So now what I want to do is I want to log in to the router. And the router in this case is R1. So I just go console R1. And now it's going to actually start up the router and display it once it starts. So we'll see another box pop up here momentarily once the router actually starts up. And there it is. And now, see how it says it's connected to Dynamips on the console port? I just hit enter to get started, and there you go. Now it's booting and showing me the router. This is the configuration file of the router. So once it gets done, we'll have an actual router prompt. Just like a router. It is a router. It's running the Cisco IOS software of the 7200 router. Now that the router has rebooted, we hit EN for enable. There's no password on it because there's no configuration file. And now what we're going to do is we're going to look at the interfaces. So IP interface brief. This shows me right now I have a fast Ethernet interface 00 that's connected to 192.168.2.10. It's up and up, which is good. And I have a fast Ethernet interface that's connected to 3.10. All right? So I have effectively two interfaces on this router that's configured. That's all I really need for my purposes. Now I know we've been using the 177 network. So the first thing I have to do is fix fast Ethernet 00 to point to the 177 network. So how I do that is I enter conft for configure from the terminal, and I enter interface F0/0, and now I enter IP address. And we're going to make the IP address what? 192.168.177.10. Why? Because we know we need an IP address that matches the actual virtual environment I have. The net mask is going to be 255.255.255.0. And we're in a Cisco, so I don't have to put the net mask. I just put it without the net mask. The net mask is there for routing, which sometimes we have to add and do. So now if I do a Control Z, it's going to say the interface router can change, and it did. And now if I do a Show IP Interface Brief, there we go. Now you see I have 177.10 up and up, okay? And now we can try to ping to one side, and we did. So now we've configured a router. We have two interfaces on the router, and we have a router talking to the host machine, which is represented by the .1. The 192.168.177.1 is the host machine. Good to go so far. So now what we want to do is we want to establish connectivity with another machine. So we have the 2003 server, and let's just see if we get lucky. Sometimes you just try to see if you get lucky. And we did. So this 2003 server is actually configured. So if I go into the 2003 server, bring up the command prompt, we beat this poor 2003 server to death. It's dying on us. I do an IP config. And what it is this is connected to the switch, and the IP address is 192.168.3.25. Okay, 192.168.3.30 is the default gateway. Right, so this is actually set up so it goes to the different default gateways and gets routed to the actual traffic. All right. Now, what we want to do is we want to ping from here. 177.1 network. And now it doesn't know how to get to the 177.1 network. Why? Because the default gateway says 192.168.3.30. And if we go look, if we go back to our Dynamips, this is 3.10. It's not 3.30. So let's see if we can fix it with that, or if we might have to manually add a route. Sometimes you got to manually add a route. So now what we'll do is we'll go into our control panel, our network connections. I believe this is network connection 2. No, that one's enabling, so it's not network connection 2. So we'll go back and control panel and network connections. Three, properties, and we'll change this to 10 because that's really our default gateway is 10. Now, if we ping, can we ping our .10? Well, we don't want a comma in there. Can't ping a 3, 10. And there we go. Now we have connectivity to that. So now that we have connectivity, we now have traffic going to the other side, which is the power of what we wanted to do. Now we want to make sure we go back and we kill this one interface that came up just to make sure that that interface doesn't cause us any problems going down. So we disable that interface because we don't need it. And now verify if we have connectivity, and we don't have connectivity now because we verified that or disabled that interface. So we're going to have to add a route, okay? Which is why I always do this in a Unix machine. So we go a route add. I can never remember how to do it, so I go and look at, okay, how do we add a route? There it is, route add. Okay, so we want to go to the 192.168. 177.0 network. The mask is 255. 255.255.0. And the gateway is 192.168.3.10. We still can't ping .1. All right, let's see if we can ping the other side. We can ping 10. Okay, so we'll live with that. So that's the main thing. We can get to 10 and get there. Okay, so we have a configuration now, and we have talking to the firewall, which is represented by the router in this case. Okay, so now what we're going to do is we're going to try to configure an access control list. Okay? So what we have here is we have an actual reply, so we know we got connectivity, but we want to make sure we got connectivity from the machine we're going to use to verify our router access control list. So on our backtrack machine, if we ping right now, it wouldn't work. We have to put in a route. So the route command is route add -net 192.168.3.0, and now you see why I put the net mask in there, because that's how you do it in actual Unix and Linux. 255.255.255.0 is the net mask, and the device is going to be ETH zeros. So once we add that route, then we can ping across the router now. So now we're pinging across the router to the other side, okay? So everything's good so far. So now we go back to our router configuration in Dynamips, and now it's time to configure that access control list. Okay? So the easiest way to do an access control list is the fastest way possible, and that's what most people do. So conf t, our terminal. Now what we're going to do is do IP access list, and we're going to make it extended. So an extended list, and we're going to call it external. Okay? Anytime you get stuck in Cisco, you hit the question mark, and it gives you suggestions of what you can type in. Okay? So what we're going to do is we're going to permit TCP any equal to 21. So permit TCP any source, any destination equal to 21. What is 21? 21 is FTP, File Transfer Protocol. So now we have that. So the next thing we're going to do is we have to put in a rule to allow it to come back. The problem is here, and it happens often, and we have to know this in our red team hacking, the administrator is using what we call loose access control list rules. Why? Because a correctly administrator access control list would actually only have, what? It would have only the IP address of the destination that the traffic is going to go to. So whatever server it is, it should only have that IP address. We take advantage of people usually allowing loose rules. And the next thing we have to do is get the return traffic. So the return traffic is permit TCP EQ21. So any source that has port 21 to any destination. Okay, so I got my syntax a little bit, but the good news is it's easy to fix. So all I do is TCP any, and what we're going to do is EQ20, so any source with a 20 port is allowed to go to any destination. Let's see if it likes that. There we go, that's much better this time. So now what we're going to do is we have now permitted traffic to our FTP server and from source port 20 back in. Okay, so this is the concept of how we're going to actually set this up. Okay, so now what we have to do is go to the next step. Well, remember, we were able to get to this machine by pinging it from backtrack. So let's go try to ping it now. And we can still ping the actual machine from backtrack. Okay, so now if we do an nmap scan, we try to scan it, everything's good. So our filter hasn't actually had the access control list come yet. So we got all this cool stuff we can do. So now let's go back to our router. Okay, so we want to do in a router. Okay, so what we have to do is we have to apply our access list. Okay, so what we do is do our question mark. Okay, so we see the different access lists we've got, and now what we have to do is we have to apply it. So what we're going to do is we're going to go back one step, conf t, and then do IP and a question mark. Now you see how this actually works. So using the question mark helps us figure out how to do our different things. So we've got an idea. So now we're going to go our interface F0/0, because this is our external interface, and now do our question mark. All right? So we've got a lot of commands, IP and a question mark. And now we've got access group. So let's do that. If we do IP access, we love Cisco because it does the actual completion for us. Now we have to give it the name. Do you remember what we named our access list? External. Now we do the question mark. In, that means inbound packets. This is 0, 0. So since it's 0, 0, it's going to be inbound packets. Okay? So what we're going to do here is, this is our router, right? So our Kali Linux machine, out here represented with the backtrack, the black hat, is going to be coming inbound into our router. So on the other side of our Dynamips router is our Windows 2003 machine. So what we're going to do here is we're going to create an access list that this black hat has to penetrate to get to the other side. So why we're doing this is because you're normally in a red teaming environment going to have filters you have to deal with. So what you're going to do is you're going to actually have to bypass this filter to get to the other side. So what we do with the access list is we apply it, and we apply it in. So when you look at the configuration for the access list, we're going to apply IP access group external in. And when we apply it, then we'll test it to see if this black hat can get to the other side of our filter. If not, we have to come up with techniques of how to do that. And that's what we're going to do. That's part of this professional red team hacking that we're covering. So now we got our IP access group external, and we do in. And now we have an actual access list. So if we go to our backtrack, see how now we can't ping? See how it tells us the packet's filtered? Well, how does it know the packet's filtered? Well, this is a dead giveaway that this packet is filtered. So if we do our Wireshark again, and we do an ampersand to background it, when Wireshark comes up here, telling us running as root, but that's okay, we know that. In Wireshark, we select our ETH0 and we do a start. And now let's go do our ping again. Watch what happens as soon as we do our ping. There's our ping. And as soon as we do our ping, what's happening? Destination unreachable. Here, let me stop the capture to make life easier. Why is it unreachable? It's unreachable. Destination unreachable, communication administratively filtered. This is what an access control list will do when we try to actually scan against an access control list. All right? So now what we have to do is get through it. Well, the good news is it's a weak access control list as we configured it. We configured it weakly so we could see. So if we go back to our scan here, and now we go try to do an nmap. Let's try to do an nmap scan and see what happens. So what happens now? Nmap comes up and says 999 filtered ports. One port's open, FTP. And we created FTP. We opened FTP for a reason so you could see this. In a red team drill, a lot of times people will have a port open to a service. So what we're going to do now is we're going to try to use a weakness in the filter to get through it. And that weakness is called the source port scan. So let's clear out our screen to get a little cleaned up here. Let's do our nmap scan again, but let's add the option -G20. The -G option in nmap gives us the capability for exploitation. It gives us the source. That's the source port. So this is the source port scan. So it's actually coming from source port 20. Because if you remember, FTP, active FTP, has port 21 is control communication, and port 20 is the data port. So now when we do this, what happens? So we're doing a source port 20 scan with nmap. And we hit the space bar, and it tells us it's about done. And look at that. Once we added the source port 20, now we have all the ports that are open on that machine. Without the source port 20, we didn't have this. We could not do this. All right? So this is the concept we want you to understand going forward when you're doing your red team hacking against devices. Devices are configured by humans. So sometimes they make a weak access control list, which is what the problem is here. This is a weak access control list. Now, what's really cool is, remember Metasploit? Well, let's go look at our Metasploit tool. So if I go in here and I do a gedit to bring up my editor, just because I don't want to have to go look for it, and there's my script.txt file, right? Okay. So now, it's going to have to be a reverse shell. So this is actually going to have to be the actual target. So now we're going to change the target, though, to 3.25. Why? Because it's got to go through the filter now. So it's a little bit different. So if we set this up and we run it in a typical Metasploit, so now we'll go back and we'll open a terminal window for Metasploit, and we'll zoom in on it so everybody's got larger text. And now we'll do MSF console. And once it comes up, remember it takes a little bit of time for Metasploit to come up for us. What we're going to do is we're just going to paste our script. So if we go back and we look at our script, so we're going to use this exploit MS08067 again. So we're just going to copy it. When Metasploit comes up, we're going to paste it. We have to use a reverse shell because if you recall from the drawing, we have to come out. So to understand that, I think I'll go back to the board and show that. So we have our Windows 2003 server machine right here. Okay? Now what we're going to do is we have to come through this. Well, we know the -G20 option works because we've shown that, the source port scan. So now what we're going to do is we're going to use Metasploit to go through the filter to the target. Now, we have to use a reverse shell because if we tried to push the shell through the filter, that would never work. So we're going to use the reverse shell technique to have the actual exploited machine, once it's exploited, send the shell back to us. So now the connection will egress out of the filter. If you recall, when we did the actual filter for the actual router, when we created it in Dynamips, we only created it on one interface. We did not create it on the other interface. So there's no filter on the egress or outbound traffic. A lot of times we run into this when we're doing testing in an environment where people forget to do egress filtering. So this is to our advantage when we're doing red teaming. So now what we're going to try to do is first we're going to try to push it through with Metasploit, try to push through the filter without doing any tricks. So let's see what happens. Okay, so what we have in now, we have Metasploit has the capability to exploit through filters. So if we take our script and we paste it, everything's set up, but if we wanted to exploit it now, it would fail. So we have to set the C port, which is the client port, and that tells Metasploit to come from that port. So it's going to come from port 20. So once we do that, if all goes well, remember exploitation is not 100%, starts the handler, trigger the vulnerability, and there we go. There's our session opened because we used the set C port option. The C port option is not well known in Metasploit, but it's what we use in Metasploit to actually penetrate and bypass a filter. So what we've effectively done here is we showed you how to use nmap to get through a weak access control list with the -G20, the source port option, and then now we've shown you how to do that with Metasploit. So now you know how to actually go through a device that has a weak filter set. And this concludes the lab on attacking devices.